All right, this is the most recent. I gave this test last year. And by the way, I believe this test has any FRQ component that I've pretty much ever seen. I can't remember anything that isn't on this test that I've seen really even since I've been teaching this class. There will be a experimental design FRQ question on the exam, and this is it. So maybe flag this video and go back and watch this one again when you're getting ready for your exam, as well as your test. All right, so this first one is, and again, sometimes I just can't come up with anything. So I'm ripping off The Biggest Loser. But I wanted there to be two factors. So that's kind of why I set this one up the way I did. So there's two teams. There's Team Hungry, and they do a hardcore diet and light exercise. So they're gonna be hungry all the time because they're gonna be, ketoing up or something. The other group is gonna work out really hard and then have a light diet. So maybe not quite as crazy, but they're still gonna eat healthy, but not as much. And then the idea here is which one helps better. Should you go nutso on working out and then just eat right, or should you go nutso on eating and work out heavily? And by the way, I can tell you that it's when you get older, you lose 10 pounds via the mouth for every 1 pound you lose in the gym. When you're younger, it's not quite like that, but anyway, that's neither here nor there. All right, so identify the treatments, factors, and response variable. This is the way that at least the last two exams have set up their problems, or two of the last three, whatever. It's been pretty consistent with this. They ask you 3 vocab terms, and then we blow it. So you gotta be careful. So the treatments are what you do to the groups. What you impose treatments. What did I impose upon this group? What did I impose upon this group? So hardcore exercise and light diet, or light exercise and hardcore, I don't know how that missed, and hardcore diet. I guess the answer key is gonna be, I had to print an answer key because somebody stole mine. So I had to print one that I'd already scanned it in. The factors are the components of the treatments, or not the components per se, but the variables of the treatments. So that was diet and exercise. A lot of us wanted to put treatments or diet and exercise in the factors, and then we write a bunch of stuff out. But you just got to be careful. Before we do the exam, we'll see several more of these, but I will absolutely set up a question where part A is going to be identify these terms, and you got to be ready to go. And then finally, the response variable is weight loss, but it has to be after 3 months. And that's not a context thing. If you just say weight loss, that's incorrect. It's weight loss after 3 months. In case you go up or down, at the point of time is a big deal. All right, so then this next one, most of the students got an I for this piece right here. So maybe this will be better for us because I got to see this test. But it says, what component of experimental design is accounted for by having the contestants stay at the network compound, and why is that important? So first of all, the 4 elements of experimental design are a compare group or a control group, randomization, replication, and control. And control is all other aspects are the same except the variable between the 2 groups. So this one is control. Since they stay at the compound, we can keep track of them. If you let people go home, they're gonna start doing whatever they want to do instead of whatever it is they're supposed to be doing because nobody's watching them. And we make poor decisions as human beings. So we want the only difference between the contestants to be the treatments. If they go home, this will cause confounding with the diet and activity level. So if you send them home and say, don't forget, you have to eat only these foods, they're gonna go home and they're gonna have that food and get hungry, and then they're gonna go and sneak something. If they're on the compound, there is nothing for them to sneak, or it's locked away where that's not gonna be an issue. All right, after the show is completed, Team Hungry wins, and the difference in the weight loss is labeled as statistically significant. What does that mean within the context of this problem? It means the difference in the weight loss was so large that it can't be accounted by chance variation due to random assignment. or random sampling, random assignment, that's pretty much the same thing. But if the total weight would have been, God, I don't even know. It depends how many contestants, but if the average weight loss was 12 pounds for one group and 13 pounds for the other, that's not statistically significant. And don't get caught up on what's the cutoff. You would say, if it was off by 1 pound, would you say one worked better than the other? I don't know. Maybe it was just that one group had people with a higher metabolism rate, or maybe who knows what? So it could just be the way I randomly assigned them. This group just had a little bit better group than the other. Now, if it's 12 pounds on average versus 32 pounds on average, then I'm going to go ahead and say that wasn't just because of the way I randomly selected the groups. That is because there's a difference, and this method is better than the other one. All right. They very much like that one. Statistically significance means that the difference cannot be attributed to chance variation due to random assignment, and I hope that's on the test, because we will kick that problem's butt, and there'll be a lot of issues worldwide with that one. All right. So the next one now, again, one of the questions will start with this as a three-parter, and then there'll be something else with those two. I'm not going to tell you exactly what it is. I don't even know what it is yet, but it'll be some combination of what you see on the front of this page. But all right, so the next one, I've done a different problem, but again, I could easily have made this concept up here instead. I think you get it. All right, a chemist is working a new formula tree food to increase growth rates in trees. She finds a grove of 100 Pacific Rim maple trees and randomly selects 50 that receive her new formula and 50 to receive no tree food at all. So what's the statistical advantage of using the same type of trees? And we've eliminated, it reduces confounding because we've eliminated the confounding variable of different tree types. So maybe this formula works really good for oak trees, but not for maple trees or vice versa. So if I only do one type of trees, I've reduced confounding. And that's great. And you say, well, why wouldn't they always do that? Well, what's a disadvantage is using the same type of tree is we can only infer the results to Pacific Rim maples, because that's the only thing we tested on. We only tested on one group. I can only infer to that group. This one, the sampling frame, is this one grove of 100 Pacific Rim maples, okay? It's not all trees. It's not even all Pacific Rim maples, to be honest with you. It would only be contained to that one group. But now we might go ahead and stretch that a little bit, but you can only infer from the group which you sampled from. So if I sampled within a small group, I can only infer to those. She finds the difference to be statistically significant. So the growth rates was big enough that it was statistically significant. Will she be able to say her tree food causes the increase of these trees' growth rate? Now, this one, I was a little lenient because I said these trees, I meant the Pacific Rim maple tree, and some people took that to being all trees. So I don't know. We were a little bit lenient on this one, but the idea here is yes, because it was a well-designed experiment, I can make a cause and effect relationship. So if it was an observational study, no cause and effect. But because this was an experiment, cause and effect, yes. All right, number 3. This is a lot like the first question on the last test with the tomato plants. This one is the Army recruit problem. So I have 50 United States Army recruits in basic training that are suffering from dehydration. The Army has a new electrolyte developed by Dr. Pepper to help hydrate soldiers faster, but it's expensive. And the Army is going to have half of the 50 do the electrolyte drink and half of them will just drink plain water. So just plain water works almost as good, and then we ain't going to buy the drinks, right? We're just going to go with plain water. So describe a completely randomized design. Then it says right here, we have different levels. What do you do? And then now explain what we would do with that. Very common. Completely randomized. Here's some new information. What would you do? How would you do it? So on this one, we write the name of 50 Army recruits that are dehydrated on slips of paper, put them in a hat, mix well, got to say mix well, randomization, and draw 25 names that will receive Dr. Pepper's electrolyte drink. The other The other 25 will receive water, and then we'll compare the results between water and the electrolyte drink. So you got it. You say that everybody will say draw out 25 names and they get one of the treatments. You must mention the other 25 received the other treatment. You can't skip that. I know it's obvious that's what's happening, but you still have to write it. And then you have to describe what you're going to compare. So make sure you get that on there too. Then it says we have 20 that are extremely dehydrated and 30 that are just classified as dehydrated. The doctor believes the level of dehydration will be a source of confounding. So there's one issue that's been pointed out, randomized block design. The advantage is it removes the confounding variable of dehydration level, or whatever it is. So when you block intentionally before you do your random assignment, and you block with purpose. I block by dehydration level because I believe that to be confounding. I think males and females will react differently. I block by gender. I think old people and young people will react differently. I block by age. That eliminates one confounding variable. It completely eliminates one. Match pair reduces all confounding, but this is one. All right, and then it says, how would you randomly assign treatments, including which groups you would compare? So block the Army recruits by dehydration level. Write the name of the 30 extremely dehydrated recruits on slips of paper, mix well, drop 15 names that will receive the water. The other 5 will get the electrolyte drink, and compare these two groups. And then basically the same for the other. Now, I will point out on this one, when they had one like this on the test, you had to mention 15 and 15 and 10 and 10. It said you had to say how many were receiving each treatment, which it really doesn't ask for it directly. If we're filling in things the right way, we probably would do that. But I just want to go ahead and point that out right now. That breaking it up, and that's why it broke up into not equal groups. And also at 25 and 25, you can't split that in half either. But the reason why they said 20 and 30 is so that you would do 15, 15, and then 10, 10. So just make sure you get that written down there. Should be fine. All right. Hopefully you did these, because listening to me talk about them is one thing. You trying it, screwing it up, and then me explaining it will do much better. Mr. Hughes randomly selects 4 classrooms that have class during 1A and asks each student in the class, when you do some of the groups but everybody in the group, that's cluster. If I take some from every class, that's stratified. Stratified reduces variability, cluster does not. 50 men and 60 women, and they're trying to make you think it's a block. We had that on the other one. Like to play tennis together for a free tennis racket promotion at Academy Sports and Outdoors. All fill out paper form and place them in the box, and the store manager draws out 3 winners. Again, everybody, regardless of what it was to start, was all thrown into one bucket, and we drew out names. That's a simple random sample SRS. Mr. Walliger asked parents to fill out a 10-question Google form. It was emailed out to all parents about the retesting policy. Voluntary response. And remember, the issue with voluntary response is that it favors change. They might actually have something called voluntary response bias, which means that when you ask something in voluntary response, it favors change. That never was in our textbook, but somebody asked me about it last year, and I would guess based on the student that asked me that it actually is a thing, and that's what it would be. Okay, describe the bias. So this one I even just said describe it, but you name it, describe it, and whether or not the sample that you get will over or underestimate the true population proportion or true population mean. So a writer of a liberal magazine asked to find out what percentage of U.S. adults feel President Biden is doing a good job as president. He sends out an email to all the 24,000 subscribers and gets a response from 1,853 of them. So this is under coverage. Anybody that does not subscribe to the Liberal magazine is not able to be part of the survey. Not because anything they did, but because of how I set up the survey. I set it up to only get the magazine subscribers. And then again, it's only an issue if you believe those who were not surveyed would have a different opinion than those who were. And I remember when we did this, several students did not know that Biden is a liberal candidate, which is fantastic. You guys shouldn't really be knowing about that stuff right now. You got other things to worry about. But that I had to answer that question several times. But since it's a liberal magazine, the support for a liberal president is going to be higher than the true population proportion is. And again, we're not going to talk about what it is. It's just going to be higher if all you ask are people that support them politically. So anyone who does not subscribe to the magazine were not able to be in the survey. The sample will overestimate the true population proportion of adults who thinks Biden is doing a good job. So there you go. There's an undercoverage. All right. A parent group is outraged to find out that only 15% of the AP Physics 1 students got a 3 or higher on the 2023 Physics 1 exam. Mr. Hennessy, Mr. Watley claimed that the students didn't study enough. The parents react by polling their own kids and report that the students studied on an average of 15.5 hours leading up to the exam. Well, clearly, no, they did not. Okay. But anyway, what's this one? So this, mostly it's response bias due to lying because students will lie to their parents. Okay. Also, the non-response, I put non-response because students who pass the test, their parents probably would not be part of this survey. The only people that are going to be messing with this are the ones whose student failed the exam. So those students who did pass their test would have a very different answers than those who did not. So we would only, and again, maybe they would have asked, this was just an answer that I took. I didn't intend for this to be an answer, but when I just remember getting that one, and they said, hey, look, if you passed your test, you wouldn't have been part of this survey. And if you pass the test, the average number of hours spent studying is going to be very different than those who did not. So that was a pretty good answer. But I thought this one was clearly that students, when they don't pass the test, first thing they do is lie to their parents to try to get out of trouble. And several of you are like, no, surely that's not how anybody does things. And if you are truly thinking that, you're like the only one, because everybody else knows exactly what we're talking about. Anyway, and then it would overestimate the true population mean number of hours for response bias. If we did the non-response, I might say I underestimate because the students who passed would have studied more for the test. Now, again, I think it was supposed to be pretty clear that there was lying going on, but another student, and again, I guess I didn't put that underestimate, but if the students who passed the test would have very different answers from those who didn't, this would underestimate the number of hours. So sorry that I put that, but it actually just kind of popped in my head as I was kind of finishing up this. So I thought I would insert that little answer in there too, but I did not say underestimate for this part right here. All right, and then here's the random digit table. Again, there's not much to talk about, excuse me. But fall varsity athletes are who we're assigning numbers to, and the ones that are selected get to take a drug test. Okay, select 2 at a time, ignoring repeats and unassigned number until I get 5 unique winners, well, not really winners, 5 athletes that will be drug tested. And I had a repeat here at 57. I had a 57 here and then a 57 right here. And then I had a 15 repeat. So I got a 15 there, and then I had another 15. So we actually had to go all the way across to the end. We had one number to spare, which we would not have been able to make another value with it. But there's the numbers. Also, by the way, we will not be counting these in the order. They can be in any order. I had a student came up, I don't even remember why, but theirs were all out of order, or not, but whatever. Several of them were in the same order, and they asked if I would count off of that, and the answer is no. No, the order of those does not matter. I would choose you to write them in the order that you got them, but it would not be required.